We've talked before about how we cannot have decimals in our final answers for fractions, so we need to get rid of them and then fully reduce. So here we're just continuing with that process. Remember, as we're trying to decide what to multiply by, we have to look at the number that has the most places to the right of the decimal. In this case, that is our numerator. So in order to turn the numerator into a whole number, we need to multiply either by 10, by 100, by 1000 in order to get that decimal moved over. So I compared the location of the decimal and the number of places to the right to the number of zeros when you're dealing with multiples of 10. So in this case, because we need to move the decimal twice, we need to multiply by something with 2 zeros, which means we need to multiply the top and the bottom by 100. As always, right, in order to not change the value of the fraction, we have to do the same thing to the top and the bottom. So now I'm going to move that decimal. So the top moves twice to the right. So I got 1,285. The denominator also moves twice to the right, but it's got one less number to the right. So that means I need to put a 0 there as that holding spot. So that becomes 250. So now that I have two whole numbers, I can go ahead and start reducing that. Numbers that end in 5 and 0, I know are divisible by 5. So I'm going to start by dividing both top and bottom by 5. So the top, I get 257. Then when I divide 250 by 5, I get 50. I'm going to use this as a chance to remind you of one way that can help you figure out whether a fraction is fully reduced. When we have numbers that we may be less familiar with, if we convert an improper fraction to a mixed number, we only have that small fraction to deal with then, and often it's easier to identify if it's fully reduced or not. So a little review on converting from an improper fraction to a mixed number. Remember that we use long division, and instead of just writing the R for remainder and then showing the number of your remainder, you write it as a fraction. When I look at 50 into 257, I see that it goes in 5 times. Well, 5 times 50 is 250. I need to figure out the difference there, so I subtract, and I get 7. The 7 becomes the numerator over 50. And also a reminder that denominators don't change between the improper fraction and the mixed number. All I have to pay attention to at this point is the 7/50ths, and I can see from that my 257/50ths is fully reduced. Because the instruction doesn't tell you what type of fraction to write, either of these are appropriate answers. Go ahead and pause the video and try B, and you could try C as well, and then go ahead, turn it back on, and watch me go through it. All right, so looking at this one, again, I pay attention to the number, the numerator or denominator, that has the most places to the right of the decimal. This time, it's in the denominator. I have the 100th place, 12 and 24 hundredths. To move that decimal over, I need to multiply top and bottom by 100. That decimal moves twice to the right. Notice that there's a 0 there because that only goes to the 10th, but it needs to move over to the 100th. So when it does that, there's the 0. So now I'm going to rewrite after the decimal's been moved. I do the same thing in the denominator, and I get 1,224. Now, I could do the same thing here. This is an improper fraction, and I could divide. Instead, this time I'm going to start reducing down, and then I may eventually convert to a mixed number. It just depends on how far I can get by dividing by different factors. So I am going to start by dividing top and bottom by 4. Given the size of these numbers, that may result in a few steps here, but that's okay. So 15,440 divided by 4 is 3,860. Now I need to do the denominator and divide that by 4, and I get 306. Well, both of those are even, so I know for sure a 2 goes in. If you're coming up with a different combination of numbers that do go in evenly, that's absolutely fine. If we can, the closer we get to a greatest common factor, the quicker these reductions will go. But again, if it's multiple steps to get to the same thing, that's absolutely fine. I always tell people, whatever you think of first, as long as it doesn't break any mathematical rules, go ahead and do it. So looking at this, I have 1,053, which I know 2 doesn't go into it. I also know that 5 or 10 don't go in, right? Those would go into the numerator here because of that 0. So it looks to me like that is probably fully reduced. You could go figure out prime factors, right, and see if there are any that are shared, or, and I'll do this again, we'll go ahead and convert it to a mixed number and see what it gives us. So we get, it's just good practice. I tell people, do the thing when you're practicing that you're least comfortable with, so that you start to be comfortable with it, and it's nice on tests to have multiple options of ways to do things. This is just an example of that. Okay, so 153 goes into 193. One time. 153. Right, and then I need to subtract. So I get 40, and then don't forget to drop that number down, right, that's left out there. We have not divided out the full number if we don't drop those numbers down. So now I need to see how many times 153 goes into 400, and it goes in 2 times. We get 2 times 3 is 6, 2 times 5 is 10. We carry that 1, 2 times 1 is 2, plus 1 is 3. And then we go ahead and do that subtraction. So 400 minus 306 is 94. And 94 cannot, or 153 can't go into 94. There's no other number to drop down. So that is the numerator of my fraction. So 94 over 153, which is just further confirmation that that is fully reduced. All right, if you haven't done so already, go ahead and pause the video and try C, and then I'll go ahead and do it for you. All right, once again, we need to pay attention to the number that has the most places to the right of the decimal. Well, in this case, the numerator is the only thing that has any decimal places. That's still what we pay attention to. You may be inclined to look at that whole number, the 15, and say, oh, I already have what I need. But remember, you have to get everything turned to a whole number. And if you do something to the top, you have to do it to the bottom. That can be confusing sometimes because it looks like there's nothing you need to do in the denominator. But in fact, again, because you cannot change the value of your fraction, you have to do something to both. All right, I just moved that down so there's a little bit more space. Now I need to move the decimal on the top over twice. So I multiply by 100. Since I do that to the top, I have to do it to the bottom. Now that negative is just going along for the ride. That's the same as the final whole number that we get, the negative of that divided by positive 15. So we can just carry that along with the number. We just have to make sure that we have it in the final answer, because if it starts a negative, it needs to end as a negative. I see that there is a 5 and a 0 at the end of each of these, so I'm going to start by dividing by 5. Okay, so I take my numerator 2,935 divided by 5, and that gives me 587 over, and I've got my denominator divided by 5, and that gives me 300. Now you may look at that and say, oh, it doesn't look to me like that can reduce any further. But again, always doing that step of either prime factors or converting to a mixed number can really help in ensuring that those are fully reduced.